Hello and welcome back, you guys. So today we are still talking about solving and writing equations, and more specifically what we are going to be talking about is how to represent variables and doing that with single variable equations. So I know that sometimes it's easier to take a word problem and try to represent them with multiple variables, but that also can sometimes make it even more confusing. So our goal today is going to take these word problems and represent them with just one variable, and then write an equation, solve it, and make sure to check it and make sure that it makes sense, okay? And so those directions are actually right here at the top of the paper. And hopefully you saw the little note at the beginning of the lesson that you could have printed these notes and, again, pasted them into your spiral notebook. Otherwise, as always, you can just pause and copy down these word problems. You definitely want to have these word problems written into your notes. That way, as we go through and annotate them, you're able to do the same thing. Because obviously, if you don't have the word problem down, then notes that have to do with word problems aren't going to make a whole lot of sense. So either way, hit pause, copy them down, or if you've already pre-printed and pasted them into your spiral notebook, then you are good to go. All right, first problem here says, Leo's garden, which is 6 meters wide, has the same area as Jen's garden, which is 8 meters wide. Find the dimensions of the two rectangular gardens if Leo's garden is 3 meters longer than Jen's garden. And you'll notice that even though this is the notes and I'm teaching them to you, if this wasn't the notes and if this was just me doing my homework or if this was a test, I would have done the exact same thing. I would have read the entire problem before actually attacking the problem, because what that does is that gives you the sense of what is this entire problem about. I always read the entire thing before I start breaking it apart or piecing it together, however you want to look at the problem. It gives you the big picture. It tells you what am I trying to do with this picture, and it kind of allows you to come up with a plan. Then once you know what it's all about, then you can go back through and actually start doing kind of the annotating or looking at it and seeing, okay, now how am I going to approach this, okay? So we know that this is a rectangular garden and we are dealing with area, okay? And we also know that they have the same area, okay? And we have two people here, so sometimes it's easy to set these up kind of in a table, but it's not necessarily in a table. I just like to set them up like, who are my two people? We have Leo and we have Jen, okay? And then we're talking about their width, right, and their length, because those are the two measurements on a rectangle, okay? And it says that Leo's garden is 6 meters wide. Just straight up, it's 6 meters wide, right? So I can actually fill that in. It's 6 meters, okay? And I'm actually going to make sure to make that note that we're in meters. 6 meters wide. And Jen's garden is 8 meters wide. And then, let's see, what else? Find the dimensions of the two rectangular gardens if Leo's garden is 3 meters longer than Jen's garden. So we don't know the length of Jen's garden, so I'm going to make her length the variable, but I know that Leo's garden is 3 meters longer, so his would be J plus 3. And then what we do know, and we already talked about it here, is that they have the same area. Now remember, to find area is going to be width times length. So Leo's area is width times length, and it's going to be the same as Jen's area, which her area is width times length. Okay, and then we can just go through and solve that equation. So I get 6j plus 18 equals 8j. 18 equals 2j. So 9 is equal to j, which means that her length is 9 and Leo's length is 12. And then it says find the dimensions. So again, dimensions are all of them. So I would want to write it out. So Leo's garden is 6 by 12 meters, and Jen's garden is 8 by 9 meters. And if we want to check our answer, the area of their gardens has to be equal to each other. So 6 by 12 would give me an area of 72 square meters. 8 by 9 would give me also an area of 72 square meters. Okay? All right, so let's take a look at this next one here, talking about the Eiffel Tower. So it says the Eiffel Tower is 497 feet taller than the Washington Monument. If each of the monuments were 58 feet shorter, the Eiffel Tower would be twice as tall as the Washington Monument. How tall is each? Okay, so a lot of information there, right? But we are talking about two things, right? We are talking about the Eiffel Tower and the Washington Monument. Okay? And then we're talking about two different situations as well. We're talking about their normal heights, and we're also talking about if they were both 58 feet shorter. Okay? So what I want you guys to do right now is I want you to try and come up with the expressions that would be filled in those four spots, okay? So pause right here and fill in the expressions that would go right there. Okay, so let's see what you did. So it started with the Eiffel Tower is 497 feet taller than the Washington Monument. So the one that I would make the variable probably is the Washington Monument, because that's the one that the Eiffel Tower is being compared to. So that would be W, and then this one would be W plus 497. Okay, and then over here, if they're each 58 feet shorter, you would just take each of those expressions and subtract them by 58. So, like that, which essentially this one just becomes W plus 439. Okay? Now the next part that we have to look at is when it says if each of the monuments were 58 feet shorter, the Eiffel Tower would be twice as tall as the Washington Monument. Okay? The Eiffel Tower would be twice as tall as the Washington Monument. So I want you to take that sentence and I want you to write the equation for that. Okay? So take that equation, or that sentence, and write the equation for it. Go ahead. All right, so if you think about it, it says the Eiffel Tower is twice the Washington Monument. And this is when they're the 58 feet shorter. So that means we're using these equations here, okay? So which one is the Eiffel Tower? That's this one, right? So I'm going to use the W plus 439 is, translates to equals, twice, looks like that, and then Washington Monument is W minus 58. Okay? All right, so now that we have our equation, we are going to go ahead and solve them. Okay, so we would just distribute. So I have W plus 439 equals 2W minus 116. Subtract the W, add the 116, and I get 555 equals W. And then add 497 to that, that's 1,052. So the Washington Monument is 555 feet, and the Eiffel Tower is 1,052 feet. Okay, making sure to box our answer, include the units, and write it out as a complete sentence. All right, you guys are going to try the next one on your own, beginning to end, so make sure read it through completely. If you need to write it out on your paper, do that first. Read it through completely, set it up, check your answer, check the validity of your answer before you submit it. Okay, it says in one basketball game, Maria scored 3 times as many points as Holly. In the next game, Maria scored 7 fewer points than she did in the first game, while Holly scored 9 more points than she did in the first game. If they scored the same number of points in the second game, how many did each score in the first game? Okay, so just be really organized with your information. Go ahead and try it. Okay, let's see how you guys did. So we have Maria and Holly, and they are lover of basketball like I am, and they played in 2 basketball games, so the first game and the second game. All right. And so it said, let's see, in one basketball game, Maria scored 3 times as many points as Holly. So I'm going to make Holly my variable. So Holly scored H amount of points. Maria scored 3 times as many points. In the next game, though, Maria scored 7 fewer points than she did in the first game. So she scored 7 fewer than herself. Okay, so whatever she scored in the first game, she scored 7 fewer. And then Holly, right here, Holly scored 9 more than she did in the first game. So here's how many Holly scored in the first game. She made 9 more than she did. Okay, so in the second game, they scored the same number of points. So the amount that Maria scored is equal to the amount that Holly scored. Okay, and then we just solve it. So that's 2H equals 16, H equals 8, and then what am I trying to solve for? How many did each score in the first game? So if I go back and plug this in, this was 8, and dang, Maria scored 24. So Holly scored 8 points, and Maria is a true baller, scoring 24 points. Okay, so remember, when you are working through this homework, you may be tempted to use more than one variable, but we really want you just to use one variable. We want to make sure that we see you using the skill. We also want to make sure that we see you, that we can see where the variables are coming from, clearly setting up the equation, and that you are writing out your answer, boxing your answer, everything like that. All right, don't forget, if you have questions or anything like that, make sure that you come to class with those questions. There's also tutorials and everything like that. Okay, we'll see you soon.